Hello everyone, welcome to the third session on game theory. In today's session, we will start our discussion of the equilibrium concepts. We'll start with the Nash equilibrium, but let's finish the games that we were doing. There was one standard game that we could not do last time, so let's just get to it. The last thing that we did was matching pennies, right? And we said that this is a game where essentially any kind of coordination cannot be sustained, right? So we have seen this kind of a matrix where every block essentially represents that what is the outcome, or what is the action profile in that particular block, right? So this H is essentially this H, and H specify that player 1 or Rahul chooses H, Anjali chooses H. In this in this scenario, when there is a match in their the coin faces that they show. In that case, Anjali gives Rahul 100 rupees, right? So Rahul gains 100 and Anjali loses exactly 100. So this was a zero sum game in which every cell summed up to zero. You can give any numbers in here, as we discussed, that essentially all the payoffs are uh, only ordinal, right? The numbers do not contain any more information than just the ordering in which they appear. All right. So let's get to the final kind of standard game that we'll do before we start the Nash equilibrium discussion. This is called the game of stag hunt. All right. So the verbal description, let's do that before we fill the form and then make the matrix. So the verbal description goes that now there are say n hunters, right? So there's a group of hunters, and they are going out to like basically hunt, right? And the idea is that the setup is that they can either go for hunting a big animal, right? So that big animal is essentially the stag. I'm sorry. That big animal is the stag. That's why it's called a stag hunt. But on the other hand, hunting a stag requires that everyone, like everyone in the group of hunters, if there are n hunters, so every one of the n hunters essentially focus, right, all their attention on hunting the stag, right? So whatever is their hunting game, everyone has to be involved in hunting the stag, as opposed to the other option is that any one player, right, or the other option with any given player is that he or she can deviate, right? He or she can choose not to coordinate and then simply go on to hunt a smaller animal like a rabbit, like a hare. ठीक? तो उस केस में क्या होगा that it's definitely sure, right? If one hunter goes out to hunt a rabbit on her own, she will definitely catch it, and the rabbit will be hers, right? So the entire rabbit will be hers. When the group coordinates, everyone coordinates, and they go for a stag hunt, they definitely catch the stag. So there is no uncertainty there. If अगर सबने हाथ लगाया है तो stag पकड़ ही लेंगे, ठीक? And then everyone will share the stag equally, right? So we'll model this game. The important is that everyone prefers that whatever share of the stag they get if the stag is hunted, that is preferred to a share to their individual rabbit that they are catching. ठीक है ना? तो इसको हम मॉडल कर लेते हैं as, like, let's fill up the form that we had. So what we have is players, right? So in this case, it's not a two-player game anymore. You have n hunters. All right. The actions for any hunter, the action is to either coordinate in the stag hunt, right, or go alone and hunt out a hare, rabbit. ठीक? The preferences are such that the best, right? So for any player I, because all players again so far are symmetric, we are not dealing with non-symmetric players, so all players are symmetric. For any given player, the best outcome is that all choose stag. ठीक है ना? सबके सब स्टैग पकड़ने में कोऑर्डिनेशन दे रहे हैं, and that means that definitely they will catch a stag, and every player including player I will get a share of the stag, right? So that's the most preferred outcome. The next best outcome, right? Next best is that player I, she chooses here, right? If any one of the other player has also chosen here, right? So the idea is that अगर बाकियों में से कोई एक भी deviate कर रहा है, तो इसका मतलब definitely stag will not be caught, and then it's better to that you yourself would have chosen to go for a hare, to go for a rabbit, rather than getting stuck coordinating while एक player deviate कर गया and the stag didn't get caught, plus you could not catch a rabbit, right? So the next best outcome is that अगर कोई दूसरा deviate कर रहा है, अगर कोई दूसरा is choosing not to go for the stag hunt, right? Then you also, तुम भी अपना इंतजाम कर लो, ठीक है? So the next is that she chooses hare, right? And the next is that she chooses hare, huh? And no matter what others do, right? So in fact you can club both of these together and say that no matter what others are doing, right? So suppose there is a given strategy of other players, all right? If this given strategy is that everyone else is choosing stag, everyone else is coordinating, then my best action as player I, then my best action is to also coordinate and go for stag, right? That is given by this, ठीक है ना, all stag. But बाकी player अगर कुछ भी और कर रहे हैं apart from the sole action profile where everyone else is also going for stag, apart from that any other profile, मतलब एक player deviate कर रहा है या 2 कर रहा है या 10 कर रहा है, right? So the next best action is कि starting from one other player deviating to n minus other players deviating, right? The best is that she chooses here. मेक सेंस? सामने वाला अगर तो सबके सब कोऑर्डिनेट नहीं कर रहे हैं तो फिर मेरा है कि मैं अपना देख लूँ, ठीक है ना? एंड द नेक्स्ट, और यू कैन से द वर्स्ट, is when you are the one coordinating and someone else gave dhoka, है ना? So that means that she chose stag and at least one other chose hare. क्योंकि एक भी गया तो वैसे भी स्टैग मिलने वाला नहीं है. And if she is the one who is stuck coordinating while someone else gave dhoka, then that's the worst outcome for her. So she would rather, of course, the best outcome is when everyone works together and gets the stag. But अगर एक ने भी धोखा दिया, so the player, for any player I, the preferred outcome is that she is part of that dhoka giving gang rather than being stuck in the coordinating gang, right? So now let's model this game in the matrix. Let's draw the matrix, right? अब matrix का दिक्कत ये है कि matrix is only 2D, right? So for matrix we will have to come up with a simplified version of this game where there are only 2 players, ठीक है? इसका अगर हमको n player में analysis करना है then we cannot work with matrix, but a matrix will capture everything that is essential to this game, right? And we will also be able to represent it in 2D, ठीक है? So again you have player 1, so you have 2 players now. Matrix will mean that we are working with the 2-player version, ठीक है? So there are 2 options, you either go for stag or hare, right? The payoffs are if both go for stag, right, then that is the best outcome for both of them, huh? The worst outcome for player 1, right, is that when she is stuck with stag but the other player deviates, right? But that outcome is less preferred to the coordination outcome, ठीक? So then she gets a 0 and she gets a 0. The other player who went for hare of course gets the rabbit, and that's one for her. Not as good as getting the stack, but कुछ तो है, ठीक है? उसको opposite ये होगा. Now this is the case when your player 1 is the one giving धोखा, where player 2 is the one who is going with stag, right? So in this case player 2 is the loser, whereas player 1 gets the hare. And the finalists जब दोनों ही अपना अपना ही देख रहे हैं, right, this block, this cell, so then you get a 1 and 1, ठीक है ना? So this, you will see that this looks a lot like the prisoner's dilemma, but the important point over here is that ये जो है ना हमारा coordination, this outcome is actually preferred over ये. Preferred over मतलब for you can think that this is the outcome. Let's say that this is the outcome in which player 2 coordinates, right? This is the outcome in which player 2 coordinates. This is the outcome in which player 2 does not coordinate. So not coordinating does have its payoff if the other person is stuck coordinating, but that is not higher than what coordinating gives you. And in prisoner's dilemma we had this ulta, right? Remember how prisoner's dilemma looked? Prisoner's dilemma was something like this. You had again, say if this was the case, quiet finky ले लो, ठीक है? Because essentially even the actions, उनके जो नाम है, that also does not matter, right? But still it will be easier. So what you had here, यहाँ पे 2-2 था, right? यहाँ पे 1-1 था. The difference was that if this person was quiet and the other person finked, then the payoff looked like this. Right? So for player 2, what you had was, for player 2 you had that coordination was fine, right? But dhoka was better. And that is what differentiates prisoner's dilemma from this. This is a crucial difference. ठीक है? तो कई बार जो है एक आर्म्स रेस का गेम हम मॉडल करते हैं, ठीक है? आर्म्स रेस क्या है? दैट arms race is essentially something that we know already. हमने बहुत सुना न्यूज़ में. It's essentially कि all countries are building weapons, right? So they are racing for the arms, for the weapons of their country in their defense system. ठीक? So of course the better outcome is that when no one builds any arms, right? Because that's dangerous, and that uses up a lot of resources, and I mean, the world would be a better place if no one had any arms, right? But the idea is that कोई भी आर्म्स रेस का क्रूशियल पॉइंट क्यों है? कोई भी कंट्री अपना वेपन सिस्टम, अपने डिफेंस को क्यों स्ट्रॉन्ग करता है? बिकॉज द अदर कंट्री इज डूइंग सो, राइट? सो उसका रिस्पॉन्स में हमको रेडी रहना है, यही जनरल फंडा रहता है. अब ये रेडी मतलब अब ये प्रेफरेंसेस को मॉडल करने के दो तरीके हो सकते हैं. वन इज दैट यू कैन मॉडल योर आर्म्स रेस as a prisoner's dilemma, and you can also model it as a stag hunt. Okay, and both these formulations, मतलब actual में arms race किस model को ज़्यादा, I mean which model better suits the arms race is an empirical question, but as theorists we can do both, right? So if we are modeling it as a prisoner's dilemma, so there are now again two options. एक क्या है option? That both of you refrain, right? Or both of you arm. So ये now the actions have different names now, right? Refrain, arm, refrain, arm. ठीक है? अगर हम prisoners dilemma के तरह मॉडल करते हैं तो तब हमारा ये केस होगा that when both refrain, this is the payoff that they get. When both arm, this is the payoff that they get, right? Of course both countries agree कि हमको arm नहीं करना है, ठीक? But दिक्कत ये है कि if this say player 1 refrains, then if the game can be modeled as a prisoner's dilemma, or the preferences of countries are like it was in prisoner's dilemma, then it would look like that this dhoka is more beneficial. But instead, if the preferences of the countries, both the countries was like those of the players in a stag hunt, then this would be the case. ठीक है ना? So this is the difference कि A दोनों मतलब for any, say for player 2, how is this ranked vis-a-vis this? How is this ranked vis-a-vis this? For player 1, how is this ranked vis-a-vis this? So then of course these are empirical matters कि actual में कैसे आम कर सकते हो, but to understand behavior of not only individuals but of countries, right? So from micro to macro level, this is how you can use games. तो अगर countries के preference ऐसे हैं due to whatever reason that there is so much distrust that if the other is refraining, you would rather arm yourself, then this is a prisoner's dilemma. But if the distrust is low, right, if there is more trust in the system, then अगर सामने वाला रेफ्रेन कर रहा है तो तुम आर्म करके तुम्हारा पे ऑफ उतना नहीं होगा जितना तुम्हारा कोऑर्डिनेट करके रिफ्रेन करके होगा. So it can be, if the countries are US and Russia, if the countries are North Korea and anyone else, right, then probably we are in the prisoner's dilemma setup. If there are countries which have more trust among themselves, like they are not exactly friends but still more trust, तो मान लो कि इंडिया और श्रीलंका, so probably this is the case. But India and Pakistan, like definitely this is the case. ठीक है? All right. So that finishes the standard games that we have done. Let's now move to the concept of equilibrium. ठीक है? तो equilibrium क्या है? अभी हम करने की क्या कोशिश कर रहे हैं? So we have specified that how you can model a particular situation as a game, a particular situation, a particular case where players' behavior is strategic, how that can be modeled as a game. ठीक है, so वो हमने डिटेल में कवर कर लिया है कि हर बार you can see that there is a verbal description given. The verbal description can be used to fill the form where you can specify the player's actions and the preferences, and finally you can create a matrix if the number of players is 2. So number of players is 2, number of actions can be more than 2. हम अभी examples करेंगे जहाँ पे हम 2 से ज़्यादा actions भी incorporate करेंगे. Of course it becomes more and more complicated as the number of actions increase, but अगर 2 player हैं तो ये किया जा सकता है. ठीक है ना? अब specify तो हमने कर दिया. Now we need to find out कि होगा क्या. ठीक, solution क्या है? How, मतलब it's a game, so solution over here exactly means that what will happen when the game is played. Okay, what will happen when the game is played? For this we will use the concept of equilibrium, but this concept of equilibrium is not, you have to think about it in more long-term kind of thing, right? So you have to think that equilibrium is not the outcome of a one-shot game, right? Equilibrium is the outcome, or equilibrium is rather characterization of a steady state. हमको इकोनॉमिक्स में पता ही है कि इक्विलिब्रियम इज माइक्रो में भी मार्केट इक्विलिब्रियम, general equilibrium. What were these? These were essentially a steady state that once you are in equilibrium, right, there's a stable social order. कि कोई भी और जो भी सिस्टम के फोर्सेस हैं, right, they are not pushing the system out of equilibrium, right? So it's stability in the sense that whoever are the players, whoever are the economic agents that are existing in that equilibrium, they don't want to get out of it because it's stable. किस terms में stable है और what does it how is it different from any random outcome is something that we will discuss, right? So what we have is that equilibrium is a steady state, right? Or you can say that it's a stable social order. Okay. So now how to get there, how to find the equilibrium of a particular game, उसके लिए हम क्या करेंगे? We'll start at the assumption of rational choice. ठीक है? So हम अभी भी, so we are still in traditional micro. The idea is that all the players are working in their own self interest. ठीक है, जैसा भी उनका हमने ये किया है, राइट, जैसा भी उनका अपना पे ऑफ फंक्शन है, वट एवर काइंड ऑफ प्रेफरेंसेज दे हैव, वेदर दे आर altruistic, whether they are selfish, whether they are perverts, whether they are kinky, doesn't matter. ठीक है ना, जो भी प्रेफरेंस है उसको वो मैक्सिमाइज, मतलब वो वाला पे ऑफ वो मैक्सिमाइज कर रहे हैं. सो इवन व्हेन यू थिंकिंग अबाउट दैट समवन इज altruistic, you can still think that there is actually no selfless altruism. Even if you are doing good for someone else, if you guys have seen Friends, you will know that there's an episode where Joey says that there's no selfless um, uh, good act. ऐसा ही कुछ था. There's no selfless charity, there's no selfless act, because whoever is whoever is doing good to others, कुछ नहीं तो कोई पैसे नहीं, कुछ recognition नहीं, at the end of the day the least that this person is getting is happiness, right? So in that sense, something is giving you happiness, something is giving you utility, you are doing it for your own self. So that is the idea that the theory of rational choice uses, that it doesn't matter what the preferences look like, everyone is trying to maximize their payoff. ठीक, now अब दिक्कत इसमें ये है कि हम जब इस kind of strategic situation में हैं, and we are in the simultaneous move game, right? That means that when one player is making a move, this player does not know कि सामने वाले ने क्या किया होगा. ठीक है, हमको तो यही हमारा assumption है that in these games, when player I moves, doesn't know what player J did. People are moving simultaneously. So then how do you choose what is best for you in this state of incomplete information, right? In this state of imperfect information, in the sense that you know, you don't exactly know कि सामने वाले ने एक्शन क्या लिया. ठीक है, सो इसका मतलब है कि तुम्हें थोड़ा अंदाजे पे काम करना पड़ेगा, right? So you will have to work on what is called a belief, right? So players have a belief. So what is a belief? A belief is a belief is what you think the other player would do, right? तुम्हें ऐसे तो करो कि जैसे तुम साथ में अगर कर रहे हो कोई भी, जैसे रॉक पेपर सीजर वाला सिचुएशन ले लो, या प्रिजनर्स डेलमा ले लो. अब तुमने सारे गेम्स कर लिए, राइट? सो प्रिजनर्स डेलमा, यू टेक योर Barkos-Stepinski, right? You take your, say, matching pennies. What you will choose, तुम्हें कुछ तो आइडिया रखना पड़ेगा कि सामने वाला क्या कर सकता है, सामने वाला क्या कर सकता है. ठीक है ना? तो इसी को हम बोलेंगे एक बिलीफ, that your action, your choice of action will depend on what you believe the other player will do, right? Now, what will be the basis of forming this belief, right? So what is the basis of belief? इसके लिए we will make two assumptions. So let's make two assumptions. Okay. The first assumption is that each player's belief is derived from or past experience in playing the game. तो हम क्या कहते हैं कि ये जो प्लेयर्स हैं ना, ये पहली बार गेम नहीं खेल रहे हैं. सो वी आर काइंड ऑफ इन अ सिचुएशन वेयर थिंग्स, मतलब दुनिया कोई नई तो है नहीं, ये कोई नया गेम इंट्रोड्यूस नहीं हुआ है. हम जो भी गेम्स को एनालाइज कर रहे हैं, दे आर मैच्योर गेम्स, राइट? सो प्लेयर्स हैव बीन प्लेइंग दिस गेम and they have experience of interacting with other players. All right, so their belief then is derived from the past experience they have in playing the same game over and over again. All right, so this is the derived from past experience in playing the game, and this is an assumption that we will essentially make for all games that we study. जो हमने 4 कैटेगरीज रखी थी, उन चारों कैटेगरीज के लिए ये assumption हम अप्लाई करेंगे that in every case players will be moved, players will be working on a belief, right? So every time the belief will be formed based on the fact that players have a past experience in playing whatever game. तो प्रिजनर्स डिलेमा में है, तो ये ऐसे मान लो कि प्लेयर आई है, ये ऐसे भी पहले भी दूसरे सस्पेक्ट के साथ अंदर रखा गया, ठीक है ना? ये मत सोचना कि नाउ व्हाट इज इम्पोर्टेंट इज दैट सिंस इट्स अ साइमल्टेनियस मूव गेम, यू हैव टू बी केयरफुल इन थिंकिंग कि ये दोनों पार्टनर नहीं है. मतलब कि ये बाहर से, जेल के बाहर से डिसाइड करके नहीं आए हैं, जेल के बाहर से डिसाइड करके नहीं आया है कि हम दोनों चुप रहेंगे या हम दोनों मैं तो तेरे को धोखा ही देने वाली हूँ, राइट? So none of these. So that's this is a point that I will come to just now. This is a qualifier, a very important qualifier. I'll just come to it, right? So this is the first assumption, that the belief is formed based on a player's past experience in playing the game, right? And the second assumption is that the players have played these games so many times, the experience is sufficiently extensive, right? So the experience is sufficiently extensive, मतलब कह लो मंजे हुए खिलाड़ी हैं, ठीक? That this essentially means that when they have been playing this game so frequently that it is sufficient to just conclude that their beliefs are actually correct. तो इसको रियल वर्ल्ड के तरीके से सोच के देखो, ठीक है? Think about the buyer seller, the Sarojini bargaining example that I gave you, right? Every time you go to Sarojini, it's a big market. It's different from the kind of market that you go to daily, जैसे कि you have your mandi, or you have your particular kirana store, right? Who you the one which you visit regularly. उसके दुकानदार से तुम्हारी जान पहचान है, ठीक? So that is not exactly a game theoretic situation, because then the essential assumption over here is that even though players have been playing this game simultaneously, it is not like they have become familiar with the other player. So in every play, they are not matched against the same player, they are matched against the similar typical player. So differentiate when you go to your local kirana store, when you go to your there are 3-4 sabzi walas say outside your society or in your society, अगर कोई सफल टाइप की दुकान है, अब उसका दुकानदार तुम्हें पता है, ठीक? Even if there are 3-4, they know you, you know them. This is not the kind of game we are modeling. This essentially assumes that you are going to bargain in a Sarojini market, right? And you are a typical buyer for a seller, and a seller is a typical seller for you. As a buyer, तुम जो दुकान के अंदर जाके पाते हो, तुम्हें पता है उसका बिहेवियर कैसे होने वाला है, तुम्हें पता है वो प्राइस ओवर कोट करने वाला है, क्योंकि उसे भी पता है कि तुम बार्गेन करने वाले हो, ठीक? राइट? सो दिस इज एन इन्फॉर्मेशन दैट बोथ ऑफ यू नो. You both know के दोनों सामने मतलब this is a belief. Exactly तुम्हें पता थोड़ी है, you don't know it, right? But you work on this belief एंड यू हैव सो मच इन्फॉर्मेशन. अभी जैसे किसी नए इंसान को भेज दो सरोजनी, किसी नए इंसान को भेजो जिसको आइडिया नहीं है, ठीक है, उसके बिलीव्स करेक्ट नहीं होंगे. मे बी दे डोंट नो कि किस लेवल का बार्गेनिंग चलता है वहाँ पे, राइट. सो देन वट एवर सामने वाला पर्सन सेज, दिस पर्सन जस्ट टेक्स इट ऑन फेस वैल्यू, वोंट बी एबल टू मैक्सिमाइज पे ऑफ. ठीक है. अगेन उस सिचुएशन में हम नहीं है. हम वो हैं जो कि हमारे जो कह लो रेगुलर बायर्स भी हैं, और वो जो सेलर्स हैं वो भी वहाँ पे कोई नया गांव से नहीं आया है. ठीक है ना, सबके सब वहाँ पे भी सीजन्ड प्लेयर्स हैं. ठीक. बट द डिफरेंस इज दैट द every time the match that is happening between you and the seller, between a buyer and the seller, that is so to say random. So the person is not specific, but the person quality is typical. तुम्हें पता है एक टिपिकल बायर ने ओवर कोट करना है, एक टिपिकल सेलर ने ओवर कोट करना है. तुम्हें पता, इफ यू आर अ टिपिकल सेलर, राइट, देन यू नो दैट अ टिपिकल बायर विल बार्गेन. सो दिस इज अ बिलीफ. कोई आपस में यारी दोस्ती है नहीं, ठीक, बट पीपल वर्क ऑन दिस बिलीफ एंड दिस इज हाउ दे चूज देयर एक्शंस दैट maximizes their belief. Alright, so these beliefs are correct is essentially an embodiment of that you are a seasoned player, right, and your experience gives you sufficient information that your beliefs essentially are correct. Alright, so this beliefs are correct are the embodiment also of the fact कि जो तुम्हारा बिलीफ है, राइट, अगर सामने वाला एक टिपिकल सेलर है तो तुम भी तो एक टिपिकल बायर हो, है ना. तो तुम भी इस गेम में अकेले नहीं हो एज अ बायर. दैट पर्सन इज ऑल्सो नॉट अकेला एज अ सेलर. देयर इज अ ह्यूज पॉपुलेशन ऑफ सेलर्स, देयर इज अ ह्यूज पॉपुलेशन ऑफ बायर्स, राइट. इट मीन्स दैट my belief as a buyer is the same as your belief as a buyer is the same as someone else's belief as a buyer. Whoever is a buyer has the same set of beliefs about the sellers. The sellers have the same set of beliefs about the buyers. And दोनों के beliefs are correct because दोनों साइड के खिलाड़ी seasoned है. ठीक है ना. और given these beliefs which are derived from past experience, right, from playing the game, given these beliefs, then essentially players are making a choice which is rational. Okay, so then you have that given beliefs players make rational choice. So the solution concept that we will be studying is essentially capturing, like we'll have two features. One feature will be the rational choice. So every player solution मतलब game का outcome होने क्या वाला है, ठीक. So in any outcome of the game, right, in any outcome that is an equilibrium, what will happen is that every player will make rational choice, right, given the beliefs, right, which are formed by past experience and then the beliefs essentially which are correct. तो इस ये याद रखना कि गेम में हमें दोनों एस्पेक्ट्स इम्पॉर्टेंट है. ये भी इम्पॉर्टेंट है कि बिलीव्स करेक्ट हों और प्लेयर्स सीजन्ड हों, पास्ट एक्सपीरियंस के साथ हों. और ये भी इम्पॉर्टेंट है कि हर पेयरिंग इन any particular round of the game, the pairing is random, that the players do not personally know each other, even though they know कि typically हर लड़की एक जैसी होती है, हर लड़का एक जैसा होता है, ऐसे बोलते हैं ना लोग कि सारी लड़कियाँ एक जैसी, सारे लड़के ऐसे ही होते हैं. तुम सारे लड़कों से तो मिले नहीं हो, ना ही तुमने सारी लड़कियों के ऊपर PhD की है, ठीक है ना. बट दिस इज टिपिकल एंड देन यू मेक योर बिहेवियर. सपोज you're going out with friends, you're trying to get into dating. तुम तो ये बिलीफ पे ही काम करते हो, गेम ही है ना. तुम तो सामने वाले को जानते नहीं हो, तुम्हें अपना बिलीफ के अकॉर्डिंग एक्शन लेना है. तुम्हें पता है तुम क्या करते हो, यू हैव दिस नोशन, You have this, all boys are like this. So then you as a girl will take actions that will maximize your payoff, whatever your payoff is, right? Whatever, however is your preference, no judgment on that. But whatever is your preference, you will try to maximize your payoff given this belief about how all boys are. Okay? Similarly, for boys, it's not one-sided. Same buyer, seller, girls, boys, teacher, student. ठीक है ना? तो ये दोनों आइडियाज इंपॉर्टेंट है दैट यू रियलाइज दैट द पेयरिंग इज रैंडम बट द बिलीव्स आर ट्रू. पेयरिंग टिपिकल प्लेयर्स के साथ ताकि तुम्हारे बिलीव्स, तुम एक्सपीरियंस भी हो, तुम्हारे बिलीव्स एक्चुअली में इक्विलिब्रियम में सही ही होते हैं. ओके, सो using this now we will give a definition of Nash equilibrium. Why do we say it's a Nash equilibrium? Because as most of you should know by now is that John Nash was a mathematician and he was also given the Nobel for game theory. Your book has a lot of there's a page of stories. It will be nice. If you've not seen the movie A Beautiful Mind, you should definitely see it. Okay, so this equilibrium concept was given by John Nash and that's why it's named after him. Movie बनाई उन्होंने John Nash पे, but there is another predecessor, von Neumann, who essentially you can say established the field of game theory. Okay, so Nash equilibrium क्या है? पहली बात तो Nash equilibrium एक for this class of game, for the simplistic games of simultaneous move and complete information जो हम अभी पढ़ रहे हैं, उस केस में Nash equilibrium is essentially an action profile. Remember action profile क्या था? Action profile था कि कहाँ गया? So action profile was essentially, in this case, if it will specify an action for each player in the order in which you player 1 के लिए action, फिर player 2 के लिए, फिर player 3 के लिए, फिर player 4 के लिए, जितने भी players हों, ठीक है ना? So it will pick an action from the action set of every player और उसको हर action profile उसको एक action assign कर देगा. So one action profile in this case, one action profile would be refrain and refrain, right? So it assigns refrain to player 1 and refrain to player 2. Another action profile is that it assigns refrain to player 1 and arm to player 2 and so on. तो a Nash equilibrium is essentially कि ये जो 4 action profiles हमारे पास available हैं, उनमें से कौन सा एक equilibrium है? So a Nash equilibrium is an action profile. In this case, the action profile, as I said, is also the outcome, right? But I would encourage you not to think of an equilibrium as an outcome, because once you start doing that, बाद में चलकर जब हम next level of games करेंगे तुम फिर confuse हो जाओगे, ठीक है ना? तो always think of an equilibrium, whether Nash equilibrium सोचो या फिर आगे जो other refinements of equilibrium that we will do. Always think of equilibrium as an action profile or a strategy profile, right? So it's an action profile A star. So A star क्या है? हर player के लिए इसने एक action assign कर रखा है. 4 players हैं तो इसका एक action, इसका एक action. So A1, A2, A3, A4 for example. ठीक है ना? So हर player के लिए action available है, मतलब एक action assigned है. So an action profile is a Nash equilibrium, right? If it has the property, so if the property that it has, मैं पूरा sentence नहीं लिख रही हूँ, you should you obviously have your books to read that. The property that it satisfies that no player can do better by deviating from the action that has been specified in this, by deviating from the action that this action profile specifies, while the other players are actually sticking to their equilibrium, like other players are sticking to the A star action profile, right? So think of it like this, that so the property is that no player benefits by deviating. Or the more precise formulation is that no player benefits by unilaterally deviating. यूनिलैटरल डेविएशन का मतलब क्या है कि सपोज ये जो भी ए स्टार है, राइट, ए स्टार हैज एक्शन स्पेसिफाइड A1 स्टार फॉर प्लेयर 1, A2 स्टार फॉर प्लेयर 2, A3 स्टार फॉर प्लेयर 4, 3 and A4 स्टार फॉर प्लेयर 4. अब फ्रॉम द पॉइंट ऑफ व्यू ऑफ प्लेयर 1, राइट, if player 2, player 3, player 4 are already choosing the actions according to A star, प्लेयर 2 ने A2 स्टार चूज कर रखा है, प्लेयर 3 ने A3 स्टार, प्लेयर 4 ने A4 स्टार, तब प्लेयर 1 के लिए A1 स्टार बेस्ट हो. If player 1 chooses any other action other than A1 star, that should make her worse off, a weaker, I mean the correct definition is that should not make her better off. She can be at the same payoff, same हो सकता है, but better नहीं होना चाहिए. ठीक है? So of course it can be possible that if the other players are choosing actions which are different than A2 star, A3 star, A4 star, तब हो सकता है कि प्लेयर 1 के लिए कुछ और बेस्ट हो. तब हो सकता है कि किसी और एक्शन चॉइस से उसे बेटर मिल जाए. But as long as the other players are sticking to this action profile, right, this has to be the best for player 1 also. And this applies to all players. From the point of view of player 2, अगर player 1 A1 स्टार में है, player 2 A1 स्टार में, player 3 A1 स्टार में है, player 4 A1 स्टार में, तो this A2 star has to be the best for player 2. Okay, so इसको हम एक काम करते हैं, let's use another notation to like write it more concisely. This is a notation that Osborne uses and most of the other books also use. This other notation is that suppose any action profile, right, so we will denote an let me say another notation. So an action profile, we will denote it using small letters, say A. A एक action profile हो गया, A star हो गया, हाँ, ये सब examples हैं. A prime हो गया, ठीक, A tilde हो गया. So whatever is the superscript that is attached to A, that is giving you different action profiles. इसने कुछ एक set of actions assign किए players को, A star ने कुछ और set of action assign किए, A prime ने कुछ और, A tilde ने कुछ और, ठीक है ना. तो जो superscript है, that will differentiate one action profile from another action profile, right? Any action of player I, right, that will be denoted by, अगर तो action profile A है, right, then the action of player I will be given by AI, right? Action of player J will be given by AJ. अगर तो action profile A star है, ठीक है ना, तो उस केस में player I का action profile क्या होगा? AI star. J का होगा AJ star. ठीक है? So the superscript will keep on identifying the particular action profile that you are specifying, and the subscript will keep on identifying the player जिसका वो action, the player whose action in that action profile is there. तो उसका भी जो भी assigned action है in that action profile. ठीक है? Similarly over here, if it is A prime, then you will have AI prime. If it is A tilde, you will have AI tilde. Similarly for AJ. ठीक है? Remember ये सारा notation है. Player I, player J का कुछ मतलब नहीं है. अगर दो ही players हैं तो कभी तुम player 1 को player I भी बोल सकते हो, कभी player 2 को player I बोल सकते हो, and then the other player becomes player J. right? Similarly, we use star um, generally for any kind of equilibrium, any kind of optimal, right? So that's why we'll go with star when we are talking about equilibrium, right? But any of them can be used. Any action profile is essentially denoted by A, and you differentiate one action profile from another by the superscript that it has. Okay? And an additional notation is that if we want to specify, suppose कि दो player नहीं है, हम अगर दो players हैं तो player IJ कर सकते हैं. अगर मान लो कि पांच players, right? In this case, what we were doing was we were saying that there are 1, 2, 3, 4 players. तो इसमें हर बार ये कहने की जगह कि फ्रॉम द पॉइंट ऑफ व्यू ऑफ प्लेयर वन, इफ प्लेयर टू चूजेज A2 स्टार, प्लेयर थ्री चूजेज A2 स्टार, प्लेयर फोर चूजेज A2 स्टार, हम ऐसे डिनोट करेंगे इसको. व्हेन देयर आर मोर प्लेयर्स, we will say that action of players other than player I. So when you are thinking of player 1, other than player 1 मतलब 2, 3, 4. ठीक है? If you are thinking of player I, then other than player I is A minus I. ठीक है? Similarly, if the action profile is A star, then you have A star minus I. Minus I मतलब जो सारा set of players है उसमें तुमने I को minus कर दिया. ठीक? Similarly, A prime minus I, A tilde minus I. तो subscript यहाँ पे जो I था, if there is only one other player, then you can say player J. If there are many other players, then you can say player minus I. All players minus the player I. Alright. So using this notation, then we can give an more concise definition of Nash equilibrium. Right. So an action profile A star is a Nash equilibrium if हमको क्या चाहिए, जो यूटिलिटी प्लेयर आई को इस एक्शन चॉइस से मिल रहा हो, given that all other players are also following the A star action, right? That should not be lower than any other action profile, any other action choice. Okay? So what we have is that if the utility that player I gets from A star, matlab from the action that has been assigned to it under A star, under the action profile A star, is at least as much as, strict inequality zaruri nahi hai, at least as much as the utility that player I gets from choosing an action from any other profile, any action that does not belong, AI prime does not belong to A star, है ना, क्योंकि ये दूसरा action profile. So is the same as, is at least as much as, greater than equal to the utility that is derived from an action AI prime, given that all other players are following the AI, like A star assigned actions, right? And it's a Nash equilibrium if this holds, if this condition holds, for every AI prime, हर दूसरा उसके मतलब A star का जो एक्शन है, A star में तुम्हें जो एक्शन असाइन किया गया, उसके अलावा कोई भी दूसरा AI prime के लिए this condition should hold, right? For every AI prime and for every player I. अगर दो ही प्लेयर हैं तो ये सेम कंडीशन प्लेयर 1 के लिए होल्ड करनी चाहिए और ये सेम प्लेयर 1 के लिए होल्ड करनी. मान लो कि प्लेयर 1 के पास 3 एक्शंस हैं, ठीक है. There are player one can like the action set, the choice of actions are 3. उनमें से एक एक्शन में A स्टार है, एक एक्शन उसका असाइन किया गया है इन A स्टार. ठीक है. Now this the action that if A star is an equilibrium, is a Nash equilibrium, that means that the action whatever has been assigned here, that should give at least as much payoff as the other two actions, and this should hold true for player 1 and for player 2. Okay, this is what is called a Nash equilibrium. और इसका सिंपली मतलब ये है कि अगर बाकी सारे लोग इक्विलिब्रियम का वाला एक्शन चूज कर रहे हैं तो यूनिलेटरली डेविएट करके कोई अपना पे ऑफ नहीं बना सकता है, कोई भी प्लेयर नहीं बना सकता. देयर कैन बी नो बेनिफिट्स फ्रॉम यूनिलेटरल डेविएशंस बाय एनी प्लेयर. यूनिलेटरल डेविएशन इज इम्पॉर्टेंट. सबके सब मिलके वहां से निकल जाए तो अलग बात, बट एज लॉन्ग एज बाकी सब वही कर रहे हैं. Alright. I'll give you an example over here which makes things very intuitively clear. Think about so we know as Indians how low our civic sense is, right? So we walk on the roads and we throw kachra everywhere. So we never think, okay, you know, डस्टबिन ढूंढ ले, बैग में डाल ले, नहीं. हमको जहाँ हमने खत्म किया हम वहीं फेंक देते हैं. ठीक है, एज अ टिपिकल इंडियन, राइट? डोंट टेक इट पर्सनली, यू मे नॉट डू इट, आई पर्सनली डोंट डू इट, बट अ टिपिकल इंडियन वुड डू इट, राइट? Now you will see that these typical Indians are walking on the road, right? Behaving typically, and then these Indians enter the metro station, right? And then you will see that these typical Indians stop doing that. None of the people do that. I know that there are metros which are उनको भी गंदा कर दिया है, कचरा कर दिया है, but in general मेट्रो में लोगों का बिहेवियर, सेम लोगों का बिहेवियर कैसे चेंज होता है, you've seen that. So then this is exactly a game theoretic situation. We are not in the two-player simplistic case. We are in a game where there are multiple players and everyone is a typical Indian, right? At any time you are matched with a different set of typical Indians, but सारे के सारे players same हैं. तो क्यों लोग ऐसा बिहेव करते हैं, क्यों ऐसा, दोनों इक्विलिब्रियम है, ऐसा सोच के देखो इक्विलिब्रियम क्यों है. क्योंकि when you are outside the metro station, suppose you yourself did not throw the garbage, right? Most of the times the reason people give for behave for throwing garbage on the road is that सभी तो कर रहे हैं, मेरे नहीं करने से क्या होगा. That is exactly that my unilateral deviation will not be beneficial to me. मैं अपना केले का छिलका अपने बैग में डालूँ, मेरा बैग खराब होगा. I will spend time searching for a dustbin. There is no dustbin, right? So a unilateral deviation is not beneficial to me. Everyone is following their equilibrium strategy, right? Everyone is following their equilibrium strategy. I can do no better by choosing any other strategy. Same people enter the metro. Everyone else is following their equilibrium strategy. No one is throwing garbage. तुम फेंक के देखो, right? Of course, तुम्हें फेंकना ही फेंकना है, तुम बच जाओगे. You can argue that I'll throw and I'll not get caught and so on. But you will not throw. You typically don't throw, right? You typically don't throw garbage. तुम्हें घुसने से पहले तुम रोड पे फेंक के आ जाते हो, बट तुम मेट्रो के अंदर चलते फिरते नहीं फेंकते ना. That is exactly this, right? So both are equilibrium situation. दोनों stable state situations हैं. Unilateral deviation कहीं भी फायदा नहीं करेगा किसी एक particular player. Of course, the same people, all of them moved out of that low level equilibrium on the roads to a high level in the sense that it's more desirable socially. That's why I'm calling it a high level equilibrium. So all of them together move to the high level equilibrium, right? But unilaterally, you try moving from here on the road, you try changing that equilibrium, नहीं कर पाओगे, है ना? And for most people that will not be beneficial also. Probably तुम मतलब you have a set of preferences that you are ready to take that trouble, but a typical Indian would not do that, right? So that's the idea, all right? So unilateral deviations cannot be beneficial when everyone else is following their equilibrium actions. ठीक? All right. So before we go ahead, I will just two things that I want to specify over here is that given this definition, there are two things that this definition does not imply, right? So what does it not imply? The first thing is that a Nash equilibrium exists. There is no guarantee that a Nash equilibrium will exist in the way that we have defined. There is also no guarantee that a Nash equilibrium is unique. So when we do examples, we will see that basically दोनों ही केसेस हो सकता है किसी गेम में नैश इक्विलिब्रियम हो और यूनिक हो सकता है किसी गेम में नैश इक्विलिब्रियम हो ही ना, हो सकता है किसी गेम में नैश इक्विलिब्रियम हो बट देयर आर मोर देन वन इक्विलिब्रियम, ऑलराइट? सो this is what we are going to handle next in our next session. I will stop here today. It's an hour. I will stop here today. In the next session, we will apply the concept of Nash equilibrium to all the games that we have been doing, right? We will see how to reach or how to solve for the equilibrium of every game that we have done so far, and also we will look at a few other examples that your book has, and after that we will also define a more we'll also come up with a more refined way or a more systematic way of finding equilibrium. So we'll start crude, and then we'll get more refined, and then we'll finish with what are called symmetric equilibrium. Okay, so all of this we'll do in the next session. So thank you for now. I'll see you in the next session. Bye bye.